Hey everybody, I wanted to take a minute and go over question number 20.8 in Brown-Lemay-Burston and see what we can do with this. Okay, so part A is saying which electrode is the cathode, and by default the other one's going to be the electrode, or the anode. Okay, so in order to do this problem we have to know kind of the basic idea of cell potential, is that the cell potential, okay, is equal to the cathode minus the potential at the anode. Okay, and so what we have is what we can do is we can look up reduction reactions. Okay, we have reduction potentials, so we don't know. Let's see. So it's the reduction reaction for silver is going to be this, reacts to form Ag, and the one for iron, Fe2 plus 2 electrons, gives us Fe. So those two reactions we can look up, and so that it turns out that it's, if I can not be moronic about it, okay, here are a list of half reactions, okay? And this, just so we know, is a table of standard reduction potentials, okay? I think that's important to do, so important to note. So here we have silver's reduction potential, okay? So it's 0.799. So what I'm going to do is right over here, I'm going to write 0.799 volts. And here's iron. Let's see if we can find iron. And this one happens to be written in alphabetical order. So here's this one at negative 0.440. Okay, so that one is negative 0.440 volts. Okay, and so the idea is that we need to arrange these things. I don't know why even that opened. Okay, we need to arrange these things, the silver and the gold, or the silver and the iron, in order to make sure that the cell potential is positive. A reaction is only going to happen when the cell potential is positive. Okay, so how do we get a positive cell potential? Okay, well, in order to get a positive cell potential, let's see, the only way to do that is by making silver here our cathode. The cathode has to have a higher cell potential than the anode. There's no way that it can happen otherwise. So the cathode is the silver. Okay, and so now the second question is, what is the standard cell potential, or the standard EMF? That's a synonym for this stuff, for cell potential. And so we can calculate that. Okay, and once we have this, now it's just kind of straightforward, but I could still call up my calculator here. Okay, and so we get that the cell potential, E naught cell, that naught stands for standard, okay, equals E, let me put this up here, E naught cathode minus E naught anode, okay, and so it's 0.799 volts minus, I don't know why that, I'm wondering if there's a dead spot in my tablet here, minus volts. Pull that up. We'll go like this. There we go. Okay. Okay. So let's see here. Volts minus negative 0.440 volts. Okay. And so now in order to do that, we go 0.799 minus a negative 0.440 When we do that, we get a voltage, a cell potential of, let me make sure that that's perfectly in the window there, of 1.239 volts. Okay, and so that's our cell potential. Okay, so there's question number 20.8 in Brown, LeMay, Burston. Have a great day.